This is a force example of finding the acceleration of a skydiver not on Earth. Here's the problem we're going to be working with. Help! I'm lost in space. I'm parachuting down through the clouds of some planet or moon, but I can't remember which planet this is. I know that my mass is 59 kilograms. My Space Explorer altimeter thingy says that I'm descending at a constant 10 meters per second. And there's this handy tag on my parachute which says drag force equals 354 newtons. Where am I most likely landing? The choices are A, Venus, where little g equals 8.9 meters per second squared, B, Jupiter, where little g equals 23 meters per second squared, or C, Titan, where little g equals 6.0 meters per second squared. Alright, let's start by thinking about the forces acting in this problem. So here's my person in the parachute. This person has weight, which points downwards, and then there's a drag force off the parachute, which points upwards. If I make a table of my forces, and I consider them in the x and the y direction, here's my coordinate system, x and y. Then drag force does not act in the x direction. Drag force acts in the y. And weight also does not act in the x direction, but it's a negative y. The problem told me something about drag. It said that drag was equal to 354 newtons. As far as weight, we usually write weight as equal to mass times little g, and that's still true even if you're not on Earth, but the value of g changes depending on what planet or moon we're talking about. And then the problem did tell me about mass. That's 59 kilograms. So now I'm going to add up these forces. And you know what, there's really nothing to add up in the x coordinate. And so I'm only going to focus on the y. The sum of the y components is equal to drag minus weight. And this is also going to be equal to the mass times the acceleration in the y direction. The problem said that the parachuter was descending at a constant 10 meters per second. That means that the net force is 0. And so this net force is equal to 354 newtons minus 59 kilograms times little g on whichever world this is. So I'm going to subtract the 354 and divide by 59 kilograms. And the result is that little g is equal to 6.0 meters per second squared. And so this tells me that I'm on Titan.